Have you ever wondered why a straw appears broken in a glass of water today? Or why a simple metal spoon flips your own reflection upside down before your eyes? These are not glitches in reality, but the fascinating results of the study of optics. Optics is the study of how light interacts with the physical world around us daily. Light travels in perfectly straight lines at incredible speeds across the vastness of empty space. However, it changes its behavior significantly when it encounters different materials in its direct path. The first master rule of this phenomenon is reflection, which occurs upon hitting a surface. Reflection happens when light hits a smooth surface and bounces off at a specific angle. This angle is equal to its arrival, a principle known as the law of reflection. While flat mirrors create clear images through specular reflection, rough surfaces behave very differently indeed. Rough surfaces scatter light in random directions, a process that we call diffuse reflection today. By understanding these fundamental bounces, we begin to decode the complex geometry of our universe. This geometry sets the stage for how we perceive everything in our daily visual experience, from our own bathroom mirrors to the vast, complex light patterns found in wild nature. Every single reflection follows these rigid mathematical laws that govern the behavior of light waves. Light behaves like a traveler that must obey the rules of the medium it traverses. When a beam strikes a polished surface, it reflects with perfect symmetry and predictable grace. This predictability is what allows us to construct mirrors that show us our own faces. Without these laws, our visual world would be a chaotic blur of unorganized light rays. Instead, we see a structured environment where every surface tells a story through reflected light. The smooth surface of a lake acts as a mirror, reflecting the sky above perfectly. Meanwhile, the craggy surface of a rock diffuses light, creating soft and gentle shadows everywhere. These interactions are the silent language of the physical world that we constantly observe daily. We rely on these bounces to navigate our surroundings and identify objects in our path. The geometry of the visual universe is hidden in plain sight, waiting for our discovery. Every reflection is a calculation performed by nature in the blink of an human eye. We observe the light and interpret the world through these precise and elegant physical rules. The study of optics reveals the hidden order beneath the surface of our visual reality. It transforms the mundane experience of looking into a deep exploration of fundamental physical laws. Light is the messenger that carries information about the shape and texture of all things. Consider the imaginary line we call the normal, drawn perpendicular to any reflective surface. The angle of incidence measures how the incoming light strikes this crucial, invisible reference line. The angle of reflection then dictates exactly how the light departs from that same point. They remain perfectly balanced, ensuring that the path of light is always mathematically consistent throughout. This balance is the secret behind the clarity of a high-quality glass mirror reflection. Even a slight deviation in the surface angle would result in a distorted, unrecognizable image. Nature demands this precision, and light delivers it with absolute consistency in every single instance. Specular reflection requires a surface so smooth that it minimizes any scattering of incoming rays. Polished metal surfaces provide the ideal environment for this type of clean, sharp visual return. In contrast, diffuse reflection occurs when the surface is microscopically uneven or textured and rough. Think of a brick wall which absorbs and scatters light in every possible direction simultaneously. This scattering prevents the formation of a clear image leaving us with only surface color. We perceive the object's presence, yet we cannot see our own reflection within its texture. This distinction between specular and diffuse reflection is vital for understanding how we see objects. Light waves are essentially energy packets that interact with matter at the atomic level daily. When they strike a boundary, they either bounce back or penetrate through the new material. Reflection is the bounce, while refraction is the bending that occurs when light enters matter. Both processes are governed by the inherent physical properties of the materials they encounter today. We can manipulate these paths using lenses to focus light into concentrated, powerful, bright beams. This ability to control light is what allows for the technology behind our modern cameras. Every lens is a masterpiece of optical engineering designed to bend light with extreme precision. By curving glass, we force light to converge or diverge according to our specific needs. This manipulation is the foundation of all telescopes, microscopes, and even our own human eyes. The world is a vast laboratory where light is constantly being reflected, refracted, and redirected. We are merely observers, learning to decode the language of these complex, beautiful light interactions. Each reflection tells us something about the surface, the light, and the surrounding environment itself. As we delve deeper into optics, we uncover the fundamental mechanisms of our own vision. The universe is illuminated by these laws, creating the vibrant reality we experience every day. Let us continue our journey into the physics of light, exploring how it shapes perception. Stay curious as we unlock the remaining mysteries of how light interacts with our world. Beyond simple reflection lies the phenomenon of refraction, which occurs when light passes through different mediums. Light travels through water or glass, and because it slows down, it is forced to bend. This bending creates the strange optical illusions that we witness in our everyday life quite often. Humans have long harnessed this bending power by crafting precision lenses from glass and clear plastic. Convex shapes are used to converge light rays, which allows us to magnify small hidden images. Conversely, concave shapes diverge light rays, which helps us to correct vision for those in need. Even our own eyes function as sophisticated convex lenses, working tirelessly to capture the world around. They project inverted images onto our retinas, which our brains then instantly correct for our perception. From the basic laws of reflection to the complex biological machinery of human sight, optics excels. Optics allows us to manipulate light to explore the microscopic world and the vast cosmic expanse. By mastering these principles, we do not just see the world, we understand its precise geometry. This geometry allows us to capture, focus, and interpret the visual beauty surrounding us every day. Light is the fundamental language of our universe, speaking through the medium of every single object. When we study refraction, we are essentially learning how to translate the light that reaches us. The way a lens curves determines exactly how the final image will appear to our eyes. Consider the camera lens, which mimics the human eye to capture moments in time forever preserved. It uses a series of glass elements to bend light precisely onto a digital sensor plate. This process is a direct application of the physics we observe in a simple water glass. Nature itself utilizes these laws, as seen when sunlight bends through raindrops to create a rainbow. Each droplet acts as a tiny prism, refracting and reflecting light to paint the summer sky. We are surrounded by these optical phenomena, yet we often overlook the math behind the beauty. The transition from reflection to refraction marks a leap in our understanding of the physical world. It reveals that light is not merely a static beam, but a dynamic, malleable force indeed. By controlling this force, we have built microscopes that reveal the hidden building blocks of life. We have also constructed massive telescopes that peer into the very dawn of our expanding universe. The same physics that bends a straw in water allows us to see distant, ancient galaxies. It is a testament to human curiosity that we have decoded these complex patterns of light. Every time you put on your glasses, you are utilizing the science of refraction to see. You are correcting the path of light so that it lands perfectly upon your sensitive retina. This biological correction is a miracle of evolution that we often take for granted each day. As we continue to explore, we find that light behaves in even more mysterious quantum ways. Yet, the classical laws of optics remain the bedrock of our visual experience and our technology. They define the boundaries of what we can see and how we interpret our physical reality. Without refraction, the world would be a blur, lacking the focus required for complex human life. We rely on these predictable bends to navigate our environment and to appreciate the visual arts. From the painter's canvas to the cinema screen, we manipulate light to evoke deep human emotion. The study of optics is truly the study of how we connect with our physical surroundings. It bridges the gap between the objective world of physics and the subjective world of sight. We are observers of a grand design, governed by the elegant, invisible rules of light rays. As light encounters new materials, it tells a story of density, speed, and structural change today. We have learned to listen to that story and translate it into tools for our advancement. The geometry of light is the geometry of our own existence within this vast, bright universe. Every reflection and every refraction adds a new layer to our understanding of the visual world. We stand at the intersection of science and wonder, watching light dance through the transparent air. The journey from the simple mirror to the complex eye is one of constant, brilliant discovery. We continue to refine our lenses, pushing the limits of what our human eyes can perceive. The future of optics promises even more incredible ways to capture and manipulate the light spectrum. We are only beginning to scratch the surface of what is possible with light-based technologies now. The physics of light remains a vibrant field, full of potential for those who seek knowledge. So, the next time you see a straw in water, remember the bending power of light. Remember the lenses in your eyes and the complex geometry that makes your vision possible today. You are witnessing a fundamental law of nature playing out in a simple, everyday glass vessel. It is a reminder that science is not just in textbooks, but in every single glance. The world is a masterpiece of light, waiting for us to observe it with clear eyes. We are the interpreters of this beauty, using our minds to decode the patterns of light. Let us continue to look closer, to question and to marvel at the physics of light. For in understanding the light, we gain a deeper appreciation for the world we inhabit daily. The story of light is the story of us, reflected and refracted through time and space. May we always keep our eyes open to the wonders that light reveals to us all. The visual universe is vast, and we are its humble, curious, and ever-observant human students.